Quiet, chapter 8 is our chapter about analytical geometry. We're going to do some, when I'm talking, you're not, boys. We're going to do some work with circles, parabolas, ellipses, and hyperbolas. So we're not going to go into huge depth, and some of this is review. At the beginning of the year, the very beginning of the year, we talked about equations like this. We said, this is number 1 in your notes. We said this is the equation of a circle. And the only information we need to know about a circle is what is its center and what is its radius. Anybody remember from our work earlier in the year, looking at that equation, what is the center?
So the radius is 2.
Actually, it's the square root of 16. So the radius is going to be 4. See how this is x squared and this is y squared? This is r squared. So the radius is the square root of that number. So the radius for this first circle is 4. The center is 1, comma, -2. Guys, every time we talked about numbers inside parentheses, way back in chapter P in chapter 1, every time we talked about numbers in parentheses, we said when you pull them out of the parentheses, you do the opposite. So this is +1, -2, and the radius is 4. So what about this circle? The center would be -3, 2, and the radius is square root of 18, which is 3 root 2. These two circles are in what we call standard form. If they're in that form, you can just look at them and tell what the center and radius are. This one is not in standard form. So somehow we have to do arithmetic on this so that it looks like these. So we need to have squared quantities. And we're going to be completing the square. So which you know how to do. So the first thing I want you to do is rearrange the equation so that the x terms are together, the two x terms are together, and I want you to leave a blank because we're going to have to stick a number in there. And then put your y terms together and leave another blank because we have to put a number in there too. And then on the other side, don't put just 6 because remember the blanks you put over here have to also be put over there to keep the equation balanced. All right, so everybody see what I did? This was the given equation. I put my x's together, left a blank, put my y's together, left a blank, and then put 2 blanks on the other side.
In our package, -81.
Oh, this is a minus?
Yeah.
Okay, thank you. That'll make this a -2. Thanks for notifying me of that before I got further in the problem. Okay, are you looking at equation number
C? It's our notes.
C in your notes? Yeah, that is a plus. So we're in our notes on the back of page 53. We're in our notes now, not the stuff I just gave you. We're in our notes on the back of page 53. It's actually the very last problem. All right, now we're going to complete the square. Who remembers, just on the x's now, just right here, look right here. Who remembers how we find the number that goes in that spot? Take half of this and square it. So half of 4 is 2 squared is 4. So I'm going to add a 4 to both sides. Biggest mistake that's made, kids forget to add it to both sides. Make sure you're adding it on both sides. Now, what about this one? Complete the square on this one.
16.
That's going to be 16. Why is it 16? Half of 8 is 4, squared is 16. Now, why did we do that? Well, this guy right here it can be factored into something that looks like this, a perfect square. X minus 2. This is x minus 2 squared. If you factored this, it would be x minus 2, x minus 2. It's x minus 2 squared. Plus, what's this one? Well, y plus 4 squared. This one, this guy right here, this thing right here, factors as y plus 4, y plus 4. It's a perfect square. And then it equals 26 when I add all that up. Now we can tell what the center and the radius are. The center would be 2, negative 4, and the radius is root 26. That's right, the square root of 26, which doesn't simplify, so we just leave it at the square root of 26. Now, we actually did those earlier in the year, so hopefully you can get through this one. Let's see, what's the first step? I need to find the center and the radius, so what do I need to do first? Let's regroup things. So I'm going to have my x squared and my 8x. Uh-oh. I don't have a y. That's actually good news because that means I don't have to do anything with it. But I'm going to take that 6 and move it to the other side. I only need to complete the square once. What number is going to go in this blank? 16. Why is it a 16? Half of 8 squared. This guy right here should be this. What is it? X plus 4. Remember, x plus 4. Plus y squared equals 22. All right, let's not get confused. What's the center of this circle? Negative 4.
Negative 1.
No. Negative 4, 0. There's nothing added or subtracted to the y, so it hasn't moved. It's at 0. Some of you were saying 1. If that were 1, you'd have something like this, right? That would be negative 1. We don't have that. So it's at 0. It's just at 0. And what's its radius? Square root of 22. All right, one more. What do we do first? This is a circle. You have to find the center and the radius. So we are going to group it. So x squared plus 4. So you don't need to put parentheses. You can if you want. We're just rearranging so that x's are together and y's are together. And remember, you're going to add 2 numbers over here, one for the x's, one for the y's, and those same 2 numbers have to be added on the other side. So, what goes here? 4. Both sides. What goes here? 4. Now remember, how do we get this number? We take half and square. Is this ever going to be negative? No. That's why I keep putting plus signs. It's always positive because you get it by squaring. What quantity is this? X plus 2. Plus, what quantity is that? Y minus 2. And that equals 18. So what's my center and radius? Center is negative 2, positive 2. And the radius is the square root of 18, which is 3 root 2. Easy peasy. So next, so stop. How do we know it's a circle? Well, one huge clue is the directions are going to say find the center and the radius. So if it's saying find the center and the radius, that means it's a circle. You can look at the equation and tell it's a circle because it has an x squared plus a y squared. Okay? A 1x squared plus a 1y squared. That's different than the next equation on the paper. So now I'm on page 54, and I'm looking at problem number 2. This is not a circle. Would you agree with me? How do I know that is not a circle? It doesn't have a y squared. If you only have one squared term, then you are a parabola. So this is a parabola, which we spent some time studying earlier, but we're going to study them a little more now. We want to find the vertex, the focus, the directrix, and the focal width. Now, we've talked about vertex, but we've never talked about any of the rest of that stuff. So this is all brand new, so try to pay close attention here. We're going to figure out what all this stuff is. It is not hard, but I would definitely recommend using a sketch. As far as the vertex goes, I want you to notice something. Are there any pluses or minuses, anything being added or subtracted in this problem?
Yeah.
So I want you to think about this example over here. When we had something added to the x, that made the center 4 left, right? But look, there was nothing added to the y, so what happened to the y coordinate of the center? It stayed at 0. If you don't have anything added or subtracted, you are vertexed at the origin. So since there's let me show you an example. If you had something like this, that vertex would not be at the origin. You want to take a wild guess where that vertex would be? At 3, -4. But because I don't have anything added or subtracted, I just stay at 0. Now, here is the key to getting everything else right. You have to know which way that parabola opens. This one opens up, but at this point, up to this point, every parabola we studied opened either up or down. And how did you know it opened down? It was a negative out there, yeah. Okay, well now we're going to have parabolas that open left or right. So I need you to make a note of this. If it's x squared, positive is up, negative is down. You already know that, hopefully. If it's y squared, positive is right and negative is left. So remember, a parabola has only one squared term. You're either going to have an x squared or you're going to have a y squared. If it's an x squared, like this one, we're going to open up or down. Since that's a positive number, we're going to open up. You were exactly right. My vertex is at the origin, and I open up, just like that. But if this had been a y squared, then I would be opening to the right. So make a note of this. You never looked at these sideways ones before, so make a note of that. Keep that in mind as we get through the problems. Okay, now, what is this focus and directrix? Does anybody happen to know? If you were an academic last year, you guys studied this, so you might know.
I didn't know it back then.
You didn't know it back then? Okay, well, I'll just tell you. Inside the parabola is a very special point called the focus. Outside the parabola is a very important line called the directrix. Now, here is the really cool part. this distance right here is the same as this distance right here. They're the same. For whatever reason, mathematicians refer to that distance as P. All you need to know is that in every parabola equation you see, this number right here is 4P. That number is always 4P. So I don't care what it is. If it's positive, negative, fraction, big number, little number, it always represents 4P. So if 4P is 8, then P is 2. Right? So that means my focus, here's my vertex, right here at the origin. My focus is up 2. So what will be the coordinates of my focus if I go up 2? 0, 2. My directrix is down 2. Well, it is not a point. It is a line. So it's y equals -2. Now, slow down. We're going down 2 to get the directrix, right? So I draw that in. Which axis does that line cross? When I draw that line in, it crosses y. Therefore, the equation is y equals. The equation is going to be whatever axis you cross. So if you had a parabola that looked like this, and its directrix was out here, then that would be an x equals line. So our focus is the point 0, 2, our directrix is the line y equals -2, and our focal width is 8. Because that guy right there, he's the most special number in the whole problem. He gives me the focal width. Mrs. Ford, what do you mean by focal width? I mean if I drew a segment right through the focus, that would be 8 units long. So if I wanted to really graph this carefully, I could plot these 2 points by going over 4 and back 4. You're not going to have to do that, but you could if you wanted to. Okay? So, how do I find the focal width? I don't find it. It's in the equation. It's right there. That number. That's your focal width. All right? So let's look at the next one. The next one is y squared equals 12x. Now, be on the lookout. Anything added or subtracted? So that tells me my vertex is still at the origin. So my vertex is still the origin because nothing has been added or subtracted. Before I find anything else, let's get this sketched. Which way does it open? Right. It's a y squared, positive 12. It opens to the right. Now that means that its focus is in here. Remember, the focus is always inside the parabola. So here, it was here because the parabola opened like that. Here it's here because it opens sideways. And if the focus is over here, the directrix is over here. Now, in order to figure out what that point is, I have to know what P is. How far over do I go? Who remembers how we find P? 4P equals 12. So if 4P equals 12, P is 3. So I'm going to start right here, and I'm going to go forward 3. So what's that point going to be? 3, 0. So your focus is 3, 0. Now if I went this way 3 to get the focus, I'm going to go this way 3, equidistant, to get my directrix, right? Which axis does it cross? So it's x equals -3. Start at the origin, count back 3, that's -3, and it's x equals. What's my focal width? 12. Easy, easy, easy. All right, so we don't have time to get the next one done. So we'll start there next time.
How was your weekend?
Yeah, I'd like to keep it like
Oh yeah, nobody leaves, so I get all my calculators back. I got a whole bunch of them out there.
I'll be coming down by you for that.
Maddie, you got one?
Oh yeah, because I'm like